Hello, everyone. Welcome to another video of the channel UNS 5 Minutos. Today we are going to talk about a fascinating topic: how did the Earth come to be? Where did this blue ball that we call home come from? What were the processes that shaped its structure, its atmosphere, and its oceans? And how did life originate in this very special environment? Let's find out together in this journey through time and space. But before, don't forget to subscribe to the channel, leave your like and activate the bell of notifications to not miss any video. Let's go! The formation of the solar system. To understand the origin of the Earth, we need to go back about 4.6 billion years, when our solar system did not exist yet. At that time, space was filled by a huge cloud of gas and dust, called the solar nebula. This cloud was mainly composed of hydrogen and helium, the lightest and most abundant elements in the universe, but it also contained small amounts of other elements, such as carbon, oxygen, iron, and nickel. These elements were produced by the explosion of ancient stars, called supernovas, that threw their remains into space. One day, something disturbed this cloud, making it start to contract and spin. This disturbance may have been caused by a shock wave of another nearby supernova, or by the gravitational attraction of a giant star. The fact is that, as the cloud contracted, it heated up and flattened, forming a rotating disk. In the center of this disk, most of the mass concentrated, forming a ball of very hot and bright gas, our Sun. But the Sun was not alone. Around it, there were a series of rings of dust and gas, that also spun. These rings were the cradle of the planets, that formed from the agglomeration of these materials. The planets closest to the Sun, such as Mercury, Venus, Earth and Mars, formed from solid dust grains, that joined by the force of gravity, forming larger rocks, called planetesimals. These planetesimals continued to collide and merge, until they formed the rocky planets, or terrestrial, that we know today. The planets farther from the Sun, such as Jupiter, Saturn, Uranus and Neptune, formed from ice grains, that also clumped together in planetesimals. But, as these planetesimals were farther from the Sun, they did not heat up as much, and they could retain a large amount of gas, mainly hydrogen and helium, that formed their huge atmospheres. That is why these planets are called gas giants, or Jovian. The formation of the Earth. One of these rocky planets that formed from the cosmic dust was the Earth. But the Earth of 4.6 billion years ago was very different from the Earth that we know today. It was a hot, dark, and violent world, without life, without water and without air. Its surface was covered by an ocean of magma, a mixture of melted rock and metals. Its core was formed by iron and nickel, that separated from the other elements by the difference of density. And its atmosphere was composed of volcanic gases, such as water vapor, carbon dioxide, methane and ammonia. The Earth was also not at peace. It suffered constant bombardments of meteorites, asteroids and comets, that brought more matter and energy to the planet. One of these impacts was especially important for the history of the Earth. About 4.5 billion years ago, an object the size of Mars, called Theia, crashed into the Earth, with a colossal force. This shock made a part of the Earth detach, forming a ring of debris around the planet. These debris joined by gravity, forming a new celestial body, our Moon. The Moon had a fundamental role in the evolution of the Earth. It stabilized the planet's rotation axis, preventing extreme climate variations. It also influenced the tides, which helped to regulate the water cycle and to create favorable conditions for life. And it protected the Earth from more impacts, serving as a natural shield. The formation of the crust, the atmosphere, and the oceans. After the great impact that formed the Moon, the Earth entered a period of relative calm, that lasted about 500 million years. In this period, the planet's surface began to cool down, forming a solid layer over the magma, the Earth's crust. The crust was thin and fragile, and was divided into several pieces, called tectonic plates. These plates moved over the mantle, the layer of magma that was between the crust and the core. The movement of the plates caused earthquakes, volcanoes and mountains, shaping the geography of the planet. The Earth's crust was divided into two types: the continental crust, which was thicker and lighter, and the oceanic crust, which was thinner and heavier. The continental crust was mainly formed by silicon and aluminum, while the oceanic crust was mainly formed by silicon and magnesium. The Earth's atmosphere also began to form in this period, from the gases released by the volcanoes. These gases were different from the ones we breathe today. They had no oxygen, but rather a lot of carbon dioxide, water vapor, methane, ammonia, and other gases. This atmosphere was very dense and opaque, preventing the passage of sunlight. It was also very hot, creating a greenhouse effect that kept the planet's temperature high. The water, which was one of the components of the atmosphere, began to condense, forming clouds. These clouds caused intense and lasting rains that fell on the planet's surface. The water from the rains accumulated in the depressions of the crust, forming the first oceans. These oceans were very different from the current ones. They were warmer, more acidic and saltier, and contained many dissolved minerals. The origin of life. It was in this hostile and primitive environment that life emerged on Earth. But how did that happen? This is one of the biggest questions of science, and there is no definitive answer. There are several hypotheses about the origin of life, but none of them have been proven. One of the most famous is the hypothesis of Oparin and Haldane, which proposes that life emerged from simple organic molecules that were formed by the action of solar energy, lightning, and electric discharges on the gases of the primitive atmosphere. These molecules would have combined into more complex molecules, such as amino acids, which are the building blocks of proteins. These molecules would have grouped into larger structures, called coacervates, which were droplets surrounded by a membrane. These coacervates would have been able to absorb substances from the environment, grow and divide, simulating a basic metabolism. Inside the coacervates, the first molecules of nucleic acid, such as RNA, would have emerged, which are capable of storing and transmitting genetic information. RNA would have been the precursor of DNA, which is the molecule that contains the code of life. This hypothesis was tested in 1953 by Stanley Miller and Harold Urey, who performed a famous experiment. They simulated the conditions of the primitive atmosphere in a device and applied electric discharges on a mixture of gases. After a week, they analyzed the liquid that was formed in the device and found several amino acids, which proved that it was possible to form organic molecules from inorganic molecules. Another hypothesis about the origin of life is the hydrothermal hypothesis, which proposes that life emerged in the hydrothermal vents, which are fissures in the ocean floor, where hot and mineral-rich water comes into contact with cold and mineral-poor water. These vents create an environment with gradients of temperature, pressure, and pH, which can favor chemical reactions. Moreover, they provide energy and protection against ultraviolet rays and cosmic impacts. In this environment, the first cells would have emerged, which would be similar to the bacteria that live in these vents today. This hypothesis was supported by evidence found in 1977 by an expedition led by Robert Ballard, who discovered a community of organisms living in the hydrothermal vents of the Atlantic Ridge. These organisms fed on chemical compounds, such as hydrogen sulfide, which were produced by the reactions between water and rocks. This process is called chemosynthesis, and it is different from photosynthesis, which uses sunlight as a source of energy. There are other hypotheses about the origin of life, such as the extraterrestrial hypothesis, which suggests that life came from outside the Earth, brought by meteorites, asteroids, or comets that contained organic molecules or microorganisms, the autotrophic hypothesis, which suggests that life emerged from molecules that were capable of producing their own food, such as chloroplasts and mitochondria, and the heterotrophic hypothesis, which suggests that life emerged from molecules that fed on organic substances present in the environment, such as viruses and bacteria. But, regardless of which hypothesis is correct, the fact is that life on Earth is an amazing phenomenon that defies the laws of thermodynamics, which say that the natural tendency is disorder and entropy. Life, on the contrary, creates order and complexity from simple and abundant elements. Life is, without a doubt, the greatest work of art of nature. Conclusion. Well, folks, I hope you enjoyed this video about the origin of the Earth and life. If you liked it, don't forget to leave your like, subscribe to the channel and share with your friends. And if you have any questions, suggestions or curiosity about this or other topics of science, leave them in the comments, and I will try to answer. A hug, and see you next time.